In this lesson, I will focus on the impulse and the momentum. So, how to make a momentum? What is a momentum? Actually, a momentum is the product of the mass and the velocity of the object. Reshumisha this formula. P is equals to m times v. Go define our momentum. Remember where re bolela ka product, re bolela ka multiplication. So that is why a momentum is the product of mass and the velocity of the object. If question e ka re ko go wena ya re, what is a momentum? So you can simply use this formula or define a momentum, where a momentum is the product of the mass and the velocity of the object. But o ka reng ge motho a ka re, what is a momentum, without using the formula? O ka reng? Actually, a momentum e no ba a mass in motion. So e ke bolela ka emotion, ke no bolela ka any moving object. So anything e lo re ya move, e lo re ya tsamaya, ga e stationary. So that particular object e na le a momentum. For example, a train that is moving. So e ra gore a train e na le a momentum. A car that is moving. So that car e na le a momentum. But ntho nngwe le nngwe e lo re ga e tsamaye e dutse. So that thing ga ena a momentum. So that is a momentum, a mass in motion. And o tlo tshwanela ke go tsebe gore a momentum is a vector quantity. Gopola gore a vector quantity re bolela ka object e le gore na le both magnitude and direction. Remember gore mass is a scalar quantity. Mass is a scalar quantity because o na le magnitude fela, but ga ona a direction. For example, o ka se re 10 kg west, o ka se re 2 liter east. So it doesn't make sense. So mass is a scalar quantity. And then a velocity is a vector quantity because the velocity in a direction. So this means momentum is a scalar times a vector. And then scalar times a vector is a vector. So that is why a momentum is a vector quantity. So that one is important. Every time o tlo tshwana gore o fe momentum a direction. But a re lebelele di units tša a momentum. Mass is in kilograms, is in kg. And then velocity is in meters per second. So ke di units tša a momentum, kilogram meters per second. A re lebelele some examples tše lore di related to this momentum. A re lebelele this example. A 15 kg block is sliding along a horizontal surface at a speed of 10 meters per second east. So ba file a 15 kilogram block, but that block is moving on a horizontal surface. This means something like this one. And then but that object is moving in this direction, east. So ba file the speed of 10 meters per second east. Remember speed with direction ke velocity. So this means ba file a velocity. And then re tseba gore a mass in motion re na le a momentum because this mass is moving. And then question e, what is the momentum of the block? This is number A. Re tseba gore P is equals to m times v. And then our mass is 15 kilogram. And then our velocity is 10. So 15 times 10 is 150. kilogram meters per second. But direction, remember, is always important. Level this thing. More nale north, west, south, east. So re a tseba gore north ke positives ge re šomiša a Cartesian plane, and then ka mo ke di negatives, and then ka mo ke di positives, and then ka mo ke di negatives. So because our momentum we are east, so this means our velocity is positive. So that is why our momentum is positive. Or you can say east, or shumisha direction yaba east. So every time you shumisha a Cartesian plane, this is north, this is west, south, and then east. So if object move west, so this means your velocity is negative. And then if it move east, this means your velocity is positive. So our level number B. What is the momentum of the block if the block is moving in westerly direction? P is equals to M times V. Our mass is 15. But in this case, because this object was in this direction, westerly direction, so this means our velocity is negative. So globally negative 10. And then our mass is negative 150 kilogram meters per second. Or you can say westerly direction. So this is our answer. And then our level our next problem. Our level this one. Calculate the velocity of the object of mass 50 kg with a momentum of 100 kilogram meters per second. So barbanyaka a velocity, and then barfile a momentum. So I think it's obvious this formula. P is equals to M times V, because this formula inally the velocity. Our momentum is 100, and then our mass is 50, and then the velocity. This means I divide both sides ka 50, or 50 cancel under ka V. And 50 cancel, and then 100 divided by 50 is 2. Therefore, our velocity is equals to 2 meters per second. Velocity is positive. This is because our momentum is really positive. So every time momentum and velocity, they are in the same direction. If our momentum is positive, so this means our velocity is positive. If our momentum is negative, this means our velocity is negative. So in this case, V is equals to 2 meters per second, or you can say east because of this direction. North, west, south, east. So this is the answer anyway. This is our last example for a momentum. Our level this example. An object of mass 150 kilogram is accelerated from a velocity of 5 meters per second to 10 meters per second in 12 seconds. This means this object 150 kilogram imuvaga velocity 5 meters per second to 10 meters per second. 5 meters per second is the initial velocity, the velocity atom, and then this is a final velocity. And then this object move in a period of 12 seconds. So, our question or ring. Calculate the initial momentum of the object. And then transfer momentum P is equals to M times V. Because this question is the initial momentum, this means globally the initial velocity. this is our initial momentum. And then mass re tlo šomiša 150 kilogram for the initial and for the final, because mass how change all the way. Then the initial is 5. And so this is our answer. This is our initial momentum. At level number B, calculate the final momentum of the object. So re tlo dira the same thing. And then our final speed is 10. 150 times 10 is 1500. And so this is our answer. And that's it for this problem. Now our level the impulse. What is impulse? Let's say, for example, on a tennis ball. Yellow is stationary. So this tennis ball is not moving. And then suddenly we apply a force. Let's say oraga this ball. And then this tennis ball it out. And then because this tennis ball is moving, this means this tennis ball and the momentum. Because remember, a momentum is a mass in motion. So oraga this ball got a certain force. And then for a certain amount of time, let's say oraga this ball got force here 5 Newton. And then for 2 seconds. So now we're what we call the impulse. Based on the definition, impulse is a certain amount of force you apply for a certain amount of time to cause a change in momentum. So it causes a change in momentum because now this ball is moving. And then any object that is moving in a momentum. So this is impulse. Impulse is cost of force times change in time. This force is the force you apply on that object, and then for a certain amount of time. So we can define your force. We can define your impulse. We shumisha this formula. Based on this formula, we can impulse is the product of a force and the time which it acts. So we're going to shumisha this definition or define your impulse. So that was the impulse. Now our level the impulse momentum theorem. Actually, the impulse momentum theorem area, impulse is equal to the change in momentum. This is true. How can level the definition of impulse? Impulse is a certain amount of force you apply for a certain amount of time. So reservoir force times time change the impulse. And then this equals the change in momentum. So that is why impulse momentum theorem area, impulse is equal to the change in momentum. So this is our impulse momentum theorem. Impulse is equal to change in P. And so impulse is F times change in T. And then that's momentum, change in momentum, P final minus P initial, get the momentum. Or you can say VF minus VI. So this is a formula or change with it. And so now our level units, reservoir impulse is equal to force times time. Reservoir force is in Newton, and so time is in seconds. So ke di-units tša the impulse, Newton times seconds. And then a re lebeletša momentum, re a tseba re di-units tša momentum ke kilogram meters per seconds. And so based on the impulse momentum theorem, I is equals to change in P. So the units tša the impulse ke Newton times seconds, and then tša momentum ke kilogram meters per seconds. So this means the units tša impulse le tša momentum ke ntho e tee, di a tshwana. So Newton per seconds equals to kilogram meters per seconds. So kilo tše le re tshwanetse o di tsebe, more special for multiple choice questions, those kind of things. So make sure you understand these things. And now let's go over some practice problems. A re lebelela this example. A constant force of 25 Newton is applied to a 20 kilogram block for 8 seconds. Ba re file a force. So this force is applied on 20 kilogram for a period of 8 seconds. O ka kgona go lemoga gore re na le an impulse, because re a tseba gore impulse ke a force e le gore e acta on a certain object for a certain amount of time. So a re lebelele our questions. Number A, what is the impulse acting on the block? Re a tseba gore impulse is equal to force times change in time. So our force is 25, and then our time is 8 seconds. 25 times 8 is 200. So this is our answer. And then it's important to tsebe gore impulse is a vector. Force re a tseba gore is a vector. Therefore, impulse is equal to force times change in time. Time is a scalar quantity. And then girile a scalar times a vector is a vector. So this means impulse is a vector. And then because impulse is a vector, this means in a direction. Impulse, it depends on the force, because our force is a vector. So if a force is a positive, so this means our impulse is a positive. If our force is negative, so this means our impulse is a negative. And then now in this case our force is positive, so that is why our impulse it was positive. So this is the answer for part A. Part B, what is the change in momentum on the block? Re tlo šomiša the impulse momentum theorem to answer this question. Re a tseba gore the impulse momentum theorem impulse is equals to change in momentum. So this means our change in momentum is equals to the impulse, and then our impulse is 200, but the units is kilogram meters per seconds. So this is the answer for part B. Number C, what is the final speed of the object if it was initially at rest? Re tlo nyaka formula e le gore e ka re fa the speed. So this formula is the change in momentum, which is equals to the speed, this formula, as you can see. And then change in momentum is 200, and then our mass is 20, and re nyaka VF. The initial it was 0, so from here re tlo divide both sides ka 20. So 200 divided by 20 is 10, and then robale VF, because VF minus 0 is just VF. Therefore our VF is 10 meters per second. this is a speed. Remember already the difference between a speed and the velocity. Velocity is a speed with direction. So a speed doesn't have a direction. So this is the speed. And then R level part D. Calculate the final momentum. So final momentum, that's about PF is equals to M times VF. And then our mass is 20, and then our VF is 10. So this is the answer. O ka kgona ho shumisha this formula, or changing P is equals to PF minus PI, and then changing momentum marnali wana already, and then wa shumisha the initial velocity wa create the momentum, because our initial velocity for this one is 0. So this means this part will create 0. And then this means changing momentum is equals to the final momentum. And then our change in momentum, it was 200. So this means this answer is correct. And so that's it for this problem. Our level this one. A tennis ball of mass 0.5 kilogram is thrown against a wall at a speed of 20 meters per second eastwards. So let's say this is a wall. Where a tennis ball is thrown in this direction eastwards, and then it rebounds perpendicularly to the wall. So this means this tennis better this wall, and then ya rebound again. This means you wela mrao, and initially it's in this direction eastwards, and then for the east that's about the positives, and then this ball ya rebound. This means it will come over the west direction, and then on the west the reservoir is negative. So this information is very important. Worry, it rebounds at a speed of 8 meters per second in the opposite direction. So this is this information. A rebound in this direction, which is the opposite. But the force exerted by the wall on the ball is 3 Newton. So this means this force is for this direction. Be careful, because I rebound, I change a direction, and then now this means our force is negative, because a force is a vector, remember. Now let's go to our question. Calculate the time of the contact between the ball and the wall. So Artoshumisha this formula. Here the impulse. Here the impulse momentum theorem. Impulse is equals to change in momentum, and then renyaga the time. So and then momentum km vf minus vi, and this is force. And then from here I can substitute mass is 0.5, and then vf. So this object level la gore o dira ga eng mo ke. So it rebounds perpendicularly to the wall and returns along the same line of motion at a speed of, so ge boela morago, this is the speed. So this means this is the final speed ge boela morago in this direction. And then now e ra gore le the velocity ya -8. So this is the velocity of -8. because it goes in the opposite direction. And then initially yeah east got the initial velocity at 20. And so our force it will be a negative because question area calculate the time of the contact between the ball and the wall. And so this all exert a force on the opposite direction. So this means globally a negative our 3 Newton. And then our answer pressure calculator it offer 4.67 seconds. So that's it for this question. Always make sure you shumisha a sketch, and then direction is very important always. And then this kind of questions this got confused every time. Try to check out the information you lo file yona ga ka check out the information wa kgona bona gore ke na le the speed ke na le the mass o ka kgona go decide gore ke tlo shumisha formula efe. Nna ke realize gore ba nyaka the time, and then ge ke lebella this information go fela ga yona ka nyaka the information e le gore e na le a time. Ke a tseba gore F-net changing t is equals to changing momentum. So after this formula it can be applicable, and then consider the direction. And so anyway this question was not that difficult. And so anyway that's it for this problem. Let's understand why batho ba go bala kudu during the accidents. So re tlo shumisha the impulse momentum theorem to explain this. According to impulse momentum theorem, F-net changing t is equals to changing momentum. And so this formula re ka ngwala in this way. Re divide both sides ka time. So this formula di a tshwana. But before ke tlo discuss about this formula, I'm sure what's about the proportionality a formula. Let's say A is equals to B over C. That's where A is inversely proportional to C, and then A is directly proportional to B. This means if A increase, this means C decrease, because this one and this one the inversely proportional. But if this one here increase, this means this one here increase, because the directly proportional. So if this one here decrease, this one here increase. If this one here increase, this one here decrease. So it's vice versa. So I should share this formula based on this information. This means if force here increase, this means this one here decrease. And then this means if this one here increase, this one here increase. And so now I lebelle gore go dira eng during the accidents. Let's say this is a moving car. Let's say koloi ye ke tsamaya in this direction, and then yo thula leboto or yo thula koloi ye nngwe. Wena o nametše ka magare ga koloi ye ke, and then this car e tsamaya ka the speed tsa 100 meters per second. So because le wena o ka magare, this means le tsamaya ka the same speed. And then now let's say if o apere a seat belt. Ge o apere a seat belt, ge koloi ye ke ya go thula this all, because o apere a seat belt, this means o fihla later on this all, because this all you protect. I mean to say because this seat belt you protect. So this means your time is increased because o fihla later. So ga re shumisha this formula, because your time is increased, so this means the force is decreased, because force and time are inversely proportional for this formula. That is why o tshwanetse go apara a seat belt gore o kgone go fihla later on the hall or on the car. And then because your time is increased, so this means the force is going to be decreased. If o sa apara a seat belt, this means time ya gago e tlo ba e nyane, o fihla fast. So if your time is decreased, this means force you are increased. And so that is why o le a fatal incidents, because your force is increased. So this is the summary of everything I was explaining. This information o ka kgona go apply again on the airbags. So ntwe botlhokwa, focus on the time and the force.